I think the reason we spend most of our time developing engineering innovations that are really biologically based, or at least medically based, is because if you want to make sure what you're working on could make a real difference, it's pretty safe if the universe of problems you're working on are medical problems. Because if you come up with something that really works, that's new and better, you're probably going to improve the quality of life for a lot of people. So we work mostly on medical products. We are always asked why we are working on some given project. And if we have had 50 projects in the last 10 years, there are 50 completely different reasons why we're working on it. This one we're working on because that guy was a friend of this other guy who told us about either a really neat problem or a really neat technology that could be applied to a problem. We don't have some big strategic plan. It's simpler than that. We're opportunists. I was in high school working in the basement of my parents' house, and my older brother was in medical school doing his medical degree and a PhD in pharmacology. And as a pediatric pharmacologist, he was trying to develop new therapies for babies with very, very, very serious diseases like leukemia. And he needed very precise, very accurate, very safe little devices that could sit in an isolate with a premature baby and deliver tiny amounts of drugs very, very accurately. And so I made equipment for him because the market was small enough that no commercial stuff was available. But after we made more and more of those devices for him to use in his research, we realized some of those devices that in fact were small enough to be the IV system for a baby, a life support system for a baby, they could sit in the pocket of an adult and give them their daily supply, for instance, of insulin if they're diabetics. And unlike my brother's application, delivering insulin to diabetics was a broad use of that technology that had lots of application for a very large number of people. So we built a business around making insulin pumps for diabetics. My first program is about convincing kids, particularly women and minorities, that unlike all the stereotypes they see, science and technology is in fact accessible and available to everybody, and it's where a lot of exciting careers are going to be for millions of kids. And I'm trying to convince the people that already know that, the professors, the grad students, the industry leaders here, that they've got to have a voice in the next generation. They've got to convince all these kids just how much fun and excitement there is in the world of science and technology. And so I was here to explain some of the new achievements we've reached with FIRST, show off the fact that this year we had 22,000 schools with competitive teams from 56 countries. We had 90,000 scientists and engineers as volunteer mentors. We had 131 university-sponsored teams. Those universities gave us almost $15 million in scholarships to distribute among the kids on the teams. We had 49 cities holding their regional events throughout our March Madness throughout the United States and around the world. The statistics don't come close to grabbing and capturing the passion in the 250,000 kids that were on these teams. But you have to be there to believe it, and I'm hoping that by being here today, we will ensure that we continue to have the same kind of fantastic growth we've had for the last 20 years.